In this video, we're going to study triangle similarity. And here are three theorems that we're going to cover very quickly in this video, but you're all very familiar with it already. So this theorem says if two angles, two corresponding angles are congruent, then these two triangles are similar. So look at the example below that I have this angle at 75 and I have this angle at 74. I'm marking it out with yellow here. And over here, I don't have the angle, but if you do 180 minus 75 minus 31, I would have 74 degrees there as well. So two angles are congruent, two corresponding angles are congruent. I've got two similar triangles. Over here, I have two angles that are congruent, that's given. I have the second pair, that's vertical angles, they're congruent. Therefore, triangle WXV is congruent to triangle ZYX. So let's see, triangle WXV is not congruent, similar to triangle ZXY. Okay, one important thing, again, order does matter. Notice that angle W and Z are corresponding angles. Angle X and angle X, and then angle V and angle Y are congruent corresponding angles. If you switch the orders, then it's not correct. Similarly, the SSS similarity theorem says that if all corresponding sides are proportional, not congruent, if they are proportional, then you have two triangles that are similar. So in this example below, if you look at 3 and 6, so 3 and 6 and 4 and 8 and 5 and 10 is 1/2, which is the scale factor of the two triangles. Then you can say triangle QPR is similar. QPR is similar to triangle TSU. Okay, so that's how we do it. And here we have, let's see, 30, 32, 35. Also another trick almost forgot to tell you is I like to line them up from the smallest to the largest. So I have 30, 32, 35, three sides. Then I go to the other triangle. I line them up from the smallest to the largest as well, which is 24, 25, and 28. And if you simplify these fractions, you will see that they don't equal to each other. So in this case, this one is not a similar triangle, whereas the one on top, they're similar. Okay? The third theorem is called SAS. So if two corresponding sides are proportional, and the included angles are congruent, then you can conclude that the two triangles are similar. So look at number 5. I have two sides. So again, I line them up from the smallest to the largest. Second one, I do the same, and that's a 20. And as it turned out, the scale factor is 4/3 if you simplify them for both of them. So this check out, yes, these two are similar because two sides are proportional and one pair of angles are congruent. And you can say triangle JKL is similar to triangle MNP. Okay? By the way, I don't know if I mentioned it, this little wiggly thing that I wrote is called the similarity statement. So that's what denotes the similarities between two triangles. So number 6, let's see. Here I have a shared angle that's being sandwiched by two sides that's given. So if these two sides are proportional, then I'm all set. So I will do smallest to the largest in the first triangle ADE. Then in the second triangle ABC, shortest is 21 and longest is 25. And as it turned out, they don't equal each other. So no, this pair is not similar to each other. Okay, so 3 theorems: AA similarities statement, SSS and SAS similarity statement, or similarity similarity theorem. So let's look at some examples here. Let's look at number 1. I have 2 parallel lines, and that's all is given. So then I know these 2 vertical angles are congruent. I know, for example, these 2 angles are are alternate interior angles. So this one is an yes. And I need to write down triangle DCE is similar to triangle FGE. Careful with the order again, and this one is an AA similarity, right? Number 3, I have a right angle, and then if this one is 39, this angle must be 51 because it's 180 minus 90 minus 39. And now, yes, I have 2 angles, 2 corresponding angles that are congruent. So therefore, SYE is similar to triangle WCH. Make sure you finish the even numbers. I'm only going to demonstrate the odd numbers. Number 5, I have 9167. So if I do 180, subtract the 2 of them, I should have 22 there. And what else is given? I don't know. Oh, okay. So I can calculate AM because I have 67 here, I have 25 here, so 180 in that big triangle LMN, 180 subtract 25, and minus 67, what's that? That should be 88. So no, I don't have 2 angles, 2 pairs of corresponding angles that are congruent. All right. Let's see if we can use SSS. So again, in this one, I just write them out from the smallest to the largest. And then I calculate and see if they equal each other. If they do, I found my scale factor. And in this case, actually, if you use your calculator or simplify it, you find out that they actually all simplifies to this would be should be 9 over 14. Okay, so yes, and it's triangle KNR is similar to triangle DES. Again, make sure that angle K is facing the middle one and angle D is facing the middle one. The largest side faces the largest angle and the shortest side is opposite of the smallest angle. So make sure that the order match up. Number 9 and number 11 are exactly the same thing. So you just need to line them up and calculate the scale factor. And so make sure you do that. Number 9, actually, I'm not going to do the arithmetic, but the answer is no. Okay? See if I have, yeah. So let's do SAS. SAS, I have number 13, I have 2 sides and I have a vertical angle. So 1 pair of congruent angles, and I just need to see if the other two, the 2 corresponding sides, do they have the same scale factor? So if I simplify it, this would be actually yes. So because this would be 1 over 4 for both of them. So these 2 triangles are congruent, and that would be SER is congruent to triangle GEF. number 15. So two triangles, I have two sides. So I'm going to try the scale factor. The first triangle, the shortest side is 22. Longer one is 33. The second triangle is 36 is the shorter one, and 54 is the longer one. And it actually, if you simplify it, you would have 11 over 12. So yes, this is similar. But I need either another side to be proportional or an angle. Because parallel lines are given, it's easier to look for congruent angles. Now, where do I find congruent angles? And that's important. Notice that angle that we need to find that's congruent has to be an included angle. So I'm deliberately looking for angle M and angle P. Are they congruent? The answer is yes, because they are corresponding angles. So therefore, I can make the similarity statement that triangle CMP is congruent to RPQ. So last one, number 17, we have two triangles overlapping, and shortest side is 14, longer side is 15. And on the big triangle, I have to add the two sides together. So it would be 14 plus 28, right? 14 plus 28 is 42. The other side is 45. So 45 is longer and 42 is shorter. So if you make the calculation, as it turned out, they actually are the same factor. So these two triangles should be similar because they have an included angle W. So if you want to prove it, you would say angle W is congruent angle W. So in this case, now you have SAS, and W happens to be an included angle. Be very careful when you write the similarity statement. So angle QWR is similar to triangle SWC. Okay, make sure the corresponding angles are matched up. All right, I'm going to stop here. There is some practices you guys should continue. Make sure you finish all the even numbers. Do enough practices. This chapter is not too hard at all because you have done so much proofs when we study congruencies. So it's fairly similar. But calculating the scale factor sometimes can be a little annoying. Okay, have a good day, and I'll see you in class. Bye, guys.